Hey everyone, thanks for joining us again. We had a few requests for how to drive a servo using Girder and a Raspberry Pi. So we put a little video together here now to show how this goes. So first off, start up your Raspberry Pi, make sure Girder's running on it. You can find instructions for that on our forum, and if it's not clear, just ask away. But if you on your Windows desktop now go start up Girder remote, you'll find that the Raspberry Pi is there. Password by default is Girder, and connect to it. So let's set up the hardware. We'll use a Raspberry Pi 2.0, and we'll have 3 wires connected to our servo, and they're all on the top row here, with the first one being the power, the ground on pin 3, and the PWM output on pin 6. And that's the only hardware PWM this one has. Then we prepared, of course, a little bit here for you. The way we're going to do this is by using the Wiring Pi library, which we've exported into Lua, so we can use all the various functions available there, and we're going to use it in PWM mode, which is pulse width modulation. This allows us to generate the signal that the servos expect and respond to. So let's go through this here step by step. The first part here is just to load the library and to set it up so that the library is ready to start accepting our commands. And the first step here is to set pin 1 into PWM mode. The Raspberry Pi, as we have it here, only has one hardware PWM output. So, and that's on the Lua Wiring Pi pin 1, which I'll show in a bit what that pin is on the actual device. But so there's only one. We can only drive one servo with this. If you want to drive more, you have to get extension boards, but this is what we're going to focus on here for now. So set it into PWM output mode. The mode has to be set to MS mark space. In the default mode, the Raspberry Pi changes the frequency on us. We don't want that. We want a steady frequency and only changing the width of the pulse. The next step is to set the divider. The Raspberry Pi clock is somewhere up in the megahertz. I don't exactly know where it is, but if you set it to 95, the divider, and the range to 4098, you actually come out at a frequency of 49.34 hertz, which is just about where we want it. We want it around 50 hertz. The exact number of frequency doesn't matter. It is the pulse width that is very important for the servos. So these 2 steps will get us to the right frequency. PWM started here. We set this variable so that we don't keep redoing this, and at changes of pulse width we don't jiggle the servo because we're changing the clock or anything like that. So we only do this if necessary. So a servo at neutral position wants a pulse width of 1.5 milliseconds. At minimum rotation about 1 millisecond, at maximum rotation 2 milliseconds. So if you do the math for that one, which is here, the 1 millisecond, this is the period of the frequency, it's 20 milliseconds, 50 hertz, comes out to 20 millisecond period. So if you divide 1 by 20 milliseconds times 4098, which is this number here, comes from the range, gives us the minimum value we can pass, the neutral value, and the maximum value. So you can actually go under and over it a little bit, but you know, use your judgment, make sure your server is not binding or anything like that. So let's turn on the PWM output and see what we get. Alright, good signal here. As you can see at the bottom here, it is 49.38 hertz with a duty cycle currently of 9.9%. And the pulse width measured by those 2 purple lines is currently at 2.1 milliseconds. So it's a little bit above 2.0. So let's fix that up a bit. There. Let's see if we can adjust this purple lines real quick, see what we measure. Alright. And we find 2 milliseconds. Yes. So that's exactly what we want. Let's move it into the neutral spot. That should be 1.5 milliseconds. Yeah, there it went a little smaller. Let's measure that. And sure enough, 1.5. So that's looking pretty good. 1.5 milliseconds. So let's try and set it to 1 millisecond and see if that comes out alright too. There. Try and measure that. It's getting pretty inaccurate here, but yeah, it looks like 1. Let's zoom in a bit. And yeah, that's pretty accurate. It's pretty spot on there. So PWM is working as we expected. Now let's hook up the servo and see if it responds as we hope. So let's have a look at a servo. This is a high-tech HS55. You can see right here. I was going to use this one here first, so I have this little rubber thingy on here, this tag, so you can see it spinning. Turns out this one's broken, but the wires are all the same. They're black, red, and yellow. With the black one is the negative, the red one is the positive, and the yellow one is the signal. So if you want to hook it up, just make sure you get them right. And then you can drive it. But again, this servo unfortunately is broken. That's why it probably wasn't in any of my planes. So I grabbed the wing off of one of my planes, and we're going to try and move that. Alright, let's have a look. So to make this easier, I've created 3 actions for us. One that centers the wing, one that goes to the minimum, and one that goes to the maximum. So this way I don't have to keep typing, but I can just trigger these actions. So let's have a look what happens to that wing when I do this. It's currently centered, so let's set it to min. Choop. You see the ailerons going up and down, and the other way. Yep. And back to center. So, as you can see, once you've got it set up, it's real easy to use. Thanks for looking, and if you have any ideas for videos, questions, suggestions, let us know. We're happy to make another video or several. Alright.